Stanford University.
I'm Lynn Orr. I'm the director of the Precourt Institute for Energy, and my task today is to ride herd on an unruly group of faculty clustered down here in the front. They've been given 5 minutes each. We'll see how well they do. But when you see me gesticulating wildly, it's because they've run out of time. And we will try in the next few minutes to give you a necessarily brief introduction to the range of things that we do here as part of the Precourt Institute and otherwise. So here we go. We have, it turns out, 198 faculty members at Stanford who do energy in some way in their teaching and research. And they're distributed across 22 departments and 13 independent labs and programs. So one of the ideas behind the Institute is to just try to find ways to bring these people together when it makes sense for them to work together to do things. So we're not actually trying to take over the whole world. And we thought it was too hard to reorganize the whole university. So instead, just as the Woods Institute has provided an intellectual meeting place for these kinds of things for the environment, we're attempting to do that in the area of energy. Stanford has a long history of energy research dating back to an Institute for Energy Studies in the 70s. The Energy Modeling Forum, which is still active and going strong, was established in the mid-70s. And in what is a kind of something like what happened to the nation as a whole, our Energy Institute shut down in the middle 80s because we couldn't fund it. Remember, the price of oil went down and we all stopped paying attention to energy for about 20 years. Then in 2002, the Global Climate and Energy Project came along. 2006, the Precourt Institute for Energy Efficiency. And then in 2009, we reorganized and brought together all these pieces in the overall Precourt Institute for Energy, which is the umbrella organization. So what are we trying to do? Well, what we really want to do, of course, is to lead the world of academic energy research, and we want to provide the people who can transform the energy landscape. So that means all of you students who are taking the energy seminar, and maybe a few besides. So we really are hoping to provide ideas and work that can help transform the energy landscape from where we are now to where we need to be, which is a set of energy systems that are much more respectful of the planet as a whole, but at the same time provide the energy the world needs to run modern technologies and modern societies. That means working across the spectrum of energy, primary energy resources and technologies, and working on the full spectrum of problems that go all the way from the technical side through to the economics and policy and regulatory structures that do that. Obviously, we want to work to strengthen the energy educational effort here at Stanford. We would like this place to produce students who really know about energy and are literate in that whole debate. We'd like to make what we do a little more visible to the outside world and to provide a single point of contact for those who want to learn about and participate in Stanford's activities. So we have 6 main elements that are represented here today, and I'll just I actually am not going to say hardly anything about them because their directors are all here and they will talk about them. They are the Precourt Energy Efficiency Center, the Global Climate and Energy Project, the TomKat Center for Sustainable Energy, the Stanford Environment and Energy Policy Analysis Center, the Stanford Slack Institute for Materials and Energy Sciences, and the Program on Energy and Sustainable Development. And we'll work our way through in this sequence of 5-minute presentations. But I hasten to point out that there's actually a lot more here as well. I mentioned the Energy Modeling Forum, for example. There's the Center for Advanced Molecular Photovoltaics, a Center on Nanostructuring for Efficient Energy Conversion, and so on and so on. So there's a lot of activity, and then there's a lot of individual faculty research group effort as well. So it's a rich, vibrant, interesting intellectual environment here at Stanford, and many of you, of course, are probably part of that as well. So, and then there's undergraduate majors and the IPER program, and there's actually a lot of stuff here that has to do with energy. So just to give you an idea of scale, one of the things that we are working on now is 5 new faculty billets. The faculty members here know that the toughest thing to get in this university is a billet, a hunting license for a new faculty position. And we have 5, so that's very exciting. We just made the first of those 5 appointments with more to come. We've done a fair amount of work where we support research through proposal competitions. So many of these are seed funding, so the Precourt Institute seed funding and the Energy Efficiency Center, these are projects that based on proposals from faculty. TomKat Center just did a group of projects related to the grid of the future. And then the Global Climate and Energy Project has provided a lot of support to Stanford research groups, mostly in 3-year projects rather than seed funding. We spend about $38 million a year in the elements that I listed on that previous slide. We have a new Energy and Environment Industrial Affiliates program that's just starting up that will help provide student support, graduate student support mostly. And then we do things like the Energy Seminar and the GCF Symposium and workshops and the various component parts as well. So there is actually quite a lot of effort here. So with that, that's the overview, and I will turn it over to Zhi-Xun Shen, who's the director of SIMES.
Yeah, I'm here to try to describe one of the components of energy sciences, Stanford, and energy research at Stanford. For this particular center, there's 2 specific things which distinguish itself. One is it's a connection to SLAC. As you know, that Stanford is one of the few places it has a national laboratory sits on its campus. Okay. So SLAC is 1 mile away from here and has a lot of research activities. The second component is that most of our research is supported by the Office of Basic Energy Sciences. So we define our own position as providing the scientific foundation for energy problems. Okay. You know, you have energy is a very broad spectrum. You have policy, you have technology, and you know, in the policy you have treaties and laws and all that. But all that need a scientific foundation underneath them. So that's what we've positioned ourselves to do, and we were also supported by the most basic component of the Department of Energy and the Office of Basic Energy Sciences. Our theme of research basically focuses on 3 of them. One of them is the dream of looking for room temperature superconductivity. Okay? That will have a transformation on the energy distribution. The other will be advanced photon conversion. The third one will be advanced energy storage. So these will be our themes. But specific to SLAC, because SLAC has some of the world's most unique capabilities in X-ray science and in ultra-fast X-ray science. I don't know how many of you know that SLAC has the world's first and only X-ray laser. Show a hand, please. So very few there. So this is a case, you know, we as an institution should be proud. It's some unique capability. And we want to make use of that. So that's what we will do. This year we have, let's see. I'm going to do the experiment. Lynn will kick me out soon. So the 5 minutes. So this is the SLAC organizing. Percy Joe is the director. I have a dual role, both as the institute director and also as the chief scientist of SLAC. And SLAC has its unique X-ray laser, and it has its synchrotron. This is an X-ray beam, which is about 1 million times brighter than the X-ray tube you would use. And this one, of course, in terms of peak brightness, is another 10 orders of magnitude brighter than this source. So that gives you a sense of that. And then there's a photon science directory. This is where our institutes belong to. Okay. So those are details. And here are basically some of the scientific. We have 10 programs being funded by the Office of Basic Energy Sciences. And you can see them in the quantum materials, ultra-fast material science. So it's a very technical component of the Precourt family. And organic materials, and interface and catalysis, and also inorganic for energy storage. As you can see that currently we're engaging 72 graduate students. That means that 72 graduate students paid On the payroll of that, it's about 14 postdocs. So it's about 80-some young, vibrant, exciting young people working with us. And that probably is the largest thing, and those are the programs we've been working on. Again, our mission is to address grand challenges in the science. Again, and let me emphasize the science of energy-related material, and we, of course, create knowledge, develop leader, and seek solutions. That's the general theme of what we want to do here at Stanford. And we wanted to become a renowned center of that activity. As I alluded to, that's our dream: room temperature superconductivity, solar power, cheaper than coal, and also electrical energy storage. And this one, of course, is another thing which is also related to first topic, low power consumption electronics. Those are the scientific problems we engage ourselves to. And that's the bigger goals, translated specific to what we do. We ask the following question: what do quantum materials have amazing emerging properties? Okay. You know, the establishment of quantum theory of solid gave us so much new technologies. One of the first of them is that of silicon. The quantum theory of solid gave us the silicon. And silicon is really unique in the following sense. In many times in the human invention, most of the invention was done empirically, but we know transistor was not. Okay. Even though this thing never worked for a long, long time, but the two of the three inventors were theorists. They insisted it should work, and eventually, of course, it worked. So the quantum theory, but there's all class of materials. The theory, quantum theory works very, very well for silicon, breaks down completely. Okay, so that's, I give you a flavor of the kind of problem we're working on, we're excited. And the other is, of course, the photon energy conversion. And the third one is how we can make various materials that can exhibit those interesting properties. Time reason, I'll stop here. And, but just to give you a scale that we have about 80 students and postdocs working with us. Of course, it's about 20 faculty members involved in the center. Yeah.
Thank you. Okay, so I have now just transformed myself into Sally Benson, who is on an airplane somewhere, and therefore I am her for the moment. She'll probably be horrified. The Global Climate and Energy Project probably, were any of you at the GCF Symposium last week? Yeah, some of you were, so you guys have all heard this. You can have a small nap here. So this is a group that is funded by 4 companies: ExxonMobil, GE, Schlumberger, and Toyota. $225 million over a 10-year period nominally. And it really works on a broad spectrum of research across primary energy resources and transformations of those resources into services, but with the focus of trying to find really deep reductions in greenhouse gas emissions. And so they do proposal competitions to try to select great projects that have potential for really changing the energy landscape. It's willing to take a little more risk than some of the typical federal funding sources, and to look a little farther out in the future. If you look at the portfolio of research, the biggest single component is the solar conversions of one sort and another, but there's some hydrogen storage, some advanced combustion, and CO2 capture and storage, and then a fair amount of electrochemistry in one guise or another in the form of fuel cells or batteries or that sort of thing. So a wide-ranging portfolio. I don't have a lot of time to talk about examples, but for example, Zhi-Xun Shen, who was just standing up here, is one of the PIs on a cool project that involves a whole new set of ideas using thermionic emissions in conjunction with solar energy conversions. So lots of potential for very high efficiency conversions. There's a group that's really trying to think about all the questions involved in in how you take sunlight, carbon out of the air, and assemble that into an energy storage material that these are great. I mean, they're little machines that take carbon out of the air, store the energy in chemical bonds, and then do that for our benefit. We call them plants. And so they do. Unfortunately, they have some other agendas, and so we're trying to persuade them to do this a little bit more efficiently. And then there's work on advanced transportation. You can imagine your battery vehicle, but now that I just heard the term, what was it called? Range anxiety for your electric vehicle. It's whether or not you have enough juice in the battery to get home. This is a set of ideas that involve using induction coils in the roadway or at charging stations where you might actually be able to charge your vehicle on the fly. So that would be fun if you could make it work. And then there are folks who are looking at geological storage of CO2 in ways that use the very reactive rocks that occur in, they're called ultramafic rocks, but are mafic rocks. These are volcanic kinds of systems. They're quite reactive, and they make magnesium and calcium carbonates, but there are plenty of challenges involved in doing that as well, because you have to get the fluids there and get them reactive. So they've supported more than 400 students. They have a big symposium every year and are helping with an energy summer school as well. So lots going on in the GCEP environment. And that is it for Sally. So now Stacy Bent will talk about the TomKat Center.
I'm going to try to be as quick and efficient as Sally just was. So let me tell you a little bit about the TomKat Center for Sustainable Energy. It's one of the newer centers. It was established within the last year through the generosity of Tom Steyer and Kat Taylor. And you can tell the focus is on sustainable energy. The mission is to harness the skills and creativity of Stanford leading science, technology, and policy experts to transform the world's energy systems for a sustainable future. So it's a very bold mission statement. What's interesting about the TomKat Center is it's trying to connect lots of different capabilities that we have here at Stanford, very interdisciplinary. The problem that we're trying to solve is inherently interdisciplinary because it involves all kinds of things, ranging from the technology. If we're looking at renewable resources for a sustainable energy system, they're intermittent, they have varying time scales. The whole distribution and transmission system is going to have to be modified from the current infrastructure if we get lots of renewables. There's information management system control. There's a whole market influence, which is going to help determine what fraction of energy is going to come from renewables. And then there's the whole environmental impact as well. So this is a broad scope. I wanted to sort of start introducing what we're focusing on with the TomKat Center with this graph from the U.S. Energy Information Administration, which basically looks at energy flow. This is just in the United States, from the supply sources, shown over here on the left, to the demand sector, shown on the right. So the first thing is you'll notice, and you've probably seen plots like this before, the majority of, let's see if this works here. Yeah, the majority of the sources are coming from fossil fuels, and only a very small fraction currently from renewable energy. This data is from 2009. So what we're looking for is increasing this component. The other interesting thing is if you look at where that energy is being used, 2/3 of it are going into basically two sectors, either electric power or transportation. And that's really where we're putting the emphasis on trying to have an impact, is on both transportation and electric power. So these are the two areas. And within that, there are lots of different topics that need to be developed. And we have expertise in a number of these at Stanford. And what we're trying to do is further develop the expertise and also tie them together. So we have to generate and convert the energy for either right into electricity or other transportation fuels. We have to move it around, transmission and distribution. There are issues of storage with both of these. Clearly for transportation, you have to have a portable fuel. That's what you use to move things around. But it's a really big issue also for electricity, because when you start to get a lot of renewables in a power grid, you have to worry about storage, because renewables are very intermittent. You don't always get the electricity at a constant rate. So we have to deal with large and small scale storage. And then there's the impact on land, water, and also air for all of these different technologies. So for example, biofuels, where are you going to be, what land are you going to be using for that, and what's the impact on the water? Same thing for large-scale wind and solar farms. So what we're looking at is promoting evaluation, analysis, and research in these different areas, these 4 different areas as they pertain to electricity and transportation. And the focus here is on both the science and engineering, as I mentioned, for these energy conversion systems. We're also looking at systems level architecture. For example, the grid. How do you manage a grid that has a lot of renewables in it? And also the social, economic, and policy issues that are going to be required to get us from the current system to a sustainable energy system. And so the last slide here is what we're doing currently. Okay, so year 1, our focus is on the sustainable power grid, or the grid of the future. And this is going to be critical for many different reasons. First of all, having a better grid architecture can help already reduce energy needs. So it's more efficient, you get more conservation, you can use it to reduce peak demand. It's going to be critical if we're going to try to get a higher incorporation of renewable sources. We can use it to reduce the cost of electricity, and also something that people around here may be familiar with, providing real-time information to consumers and also the utilities. So we've launched a program in year 1 to do this through a few different things. The first that Lynn already mentioned is a set of seed grants that we're going to be funding. We had a request for proposals, ran that over the summer, and we're going to announce shortly the ones that we're funding, but we've picked some very, very good projects to fund over a 2-year period in the area of the sustainable grid. And we're also involved in organizing various workshops this year on, for example, grid integration of renewables is going to be one of them, and also the smart grid. So we're involved in grid development in this first year of the center.
I think you're next.
Thanks, Stacy. Okay. We were born as the Precourt Institute for Energy Efficiency. Once the Precourt Institute for Energy was created, we would have had terminal confusion if we were the Precourt Institute for Energy Efficiency as the Precourt Institute for Energy. So we're now the Precourt Energy Efficiency Center. PEEC, which is part of PI, we're a little bit of a piece of the pie here. And what we're about is we're focusing on how we use energy. Most of the rest that you've heard about, not exclusively, most of the rest is how you produce energy. We've taken the view that the essential thing we can do is really pay attention to how we use energy. So the Precourt Energy Efficiency Center was established about 4 years ago, initial funding from J. Precourt, and we've had subsequent funding from several other organizations. Our mission is really to improve opportunities for implementation of energy efficient practices, technologies, and systems, focusing on the use of energy. And I'll get back to what I mean by energy efficient, because I have a definition that's somewhat different than many other people use it. How we operate is mostly grants to faculty, student teams throughout Stanford. And if you go on our website, which is peec.stanford.edu, you can see the list of the many faculty members that we have provided grants to and the student teams now. We have 2 conferences, the Silicon Valley Energy Summit and the Behavior, Energy, and Climate Change Conference. This one is coming up in November. The first one was in June. And if anybody would be interested in participating in the one that we had last June, you now can. Because on our website, we have videotaped, actually Justin Warren sitting in the back here, has videotaped the whole of the conference, and you can go on our website and see every session from start to bottom of this energy summit. And then we have some internal research. I talked about energy efficiency as a particular definition. What I think about is reductions in energy use while we increase economic efficiency. So trying to focus on not just every way you reduce the use of energy, we want to think of those for which the benefits exceed the cost, for which you increase economic efficiency. So if we think of energy efficiency improvement, I think of this upper quadrant where we both decrease energy use and increase economic efficiency. The question is, are there any things that fall into that category? And I've put a whole bunch of things on here. I've limited this because I think at this point you're straining your eyeballs. And if I put any more, that you wouldn't be able to see them at all. But I've color-coded them because I think it's important to recognize some of them in yellow require new technology. So if we're moving forward in energy efficiency, technological advances are important. Some of them are in green that have to do with laws and regulations, some which have been passed, but they have to be implemented, others that haven't really been implemented or passed. And the white don't need either new technology or new laws or regulation, but have to do with human behavior. Human behavior governed by the economic system or non-economic factors in that energy system. So within this space, what do we do as a center? Because that's, when we think about how we use energy, it's really ubiquitous. We think about this sort of as a matrix. There's about 5 sectors that we can focus on. And the biggest focus has been on buildings and transportation, with some on electric distribution, some on industry, some on appliances. But more we think about the rows in this matrix. And that's how we think about it. We've got work in engineering, a lot in energy modeling, various modeling activities, systems analysis, very significant concentration of behavior, and significant concentration in policy. If you remember that graph that Lynn showed at the beginning, and you see how much was in various schools, it was H&S, science was a big one, engineering is a big one, earth sciences. Then when we get to H&S, humanities and social sciences, or law school, or education school, it looks very small. The nice thing is, if you start dealing with behavior and policy, all those little things have to expand. And I think by about now, in the couple of years since our institutes have been together, we've probably now doubled the number of people from the numbers that Lynn has there in the graph to what we see now, because it brings in a whole different community of people. So next, I got the T sign, I'm over, and so Frank Wolak.
Is this? All right. Ooh, doesn't come up very well on the screen here, but I'll just go from what I've got. So what I'd like to talk about is PESD, which is Program on Energy and Sustainable Development. We're essentially an East Campus center, if West Campus is the engineering side. We're basically on the blending economics, political science, law, business. And the big thing that we're interested in is what you could say is try to really deal with these issues in the sense that the business models and things associated with the energy and environment sector are constrained by political constraints, legal framework, regulatory process. And what we're about is really trying to understand those so that effectively what we can do is try to get these implemented, because as I say in the title of the slide here, is that technology is important. Of course, it defines what is feasible, but often what is feasible doesn't happen, and largely doesn't happen. I mean, the best one I can think of is carbon pricing. We'd all sit there and say, we know that this is the most economically efficient way to deal with the greenhouse gas emissions problem. The chances of it being implemented politically of declining. Similarly with transmission expansions to support renewable deployment, one of the big problems is not that people don't want to build renewable generation facilities. There's many, many people out there ready to build. The trouble is that the places where the wind resources are the best, in terms of the amount that you get out, there's no transmission to get there. No one wants to also let the transmission lines get there to access the renewable resources. The other is dynamic pricing. We have massive amounts of technology available to implement dynamic pricing for electricity to get the sorts of things that Jim's talking about with energy efficiency, but the politics of implementing that. So, I mean, there are many examples, and that's the thing that we're particularly interested in. So the areas that we're currently undertaking research is on climate policy, things like for the cap and trade, renewable portfolio standards, low carbon fuel standards in the transportation sector. The other is thanks to Stacy of the support from the TomKat Center for a project we're working on with transmission policies to support this renewable integration. And then finally, things having to do with active participation, so dynamic pricing. We've run a number of behavioral modeling the impacts of dynamic pricing for various utilities, trying to help them to come up with pricing programs that are going to make sense for managing both the intermittency of renewables as well as for limiting the amount of peaker, typically dirty peaker units that you need run close to load centers. And then we also have a project on national oil companies in that one of the big things I think probably most people here may not know is roughly probably 75% of the world's oil resources are owned by national oil companies. Think Hugo Chavez. In other words, that may not have the same incentives to extract those resources and make use of them as say, the private or international oil companies. And then also project looking at natural gas. A big area here is unconventional natural gas is an area that is really opened up. And then coal, the world's fastest growing fossil fuel, is essentially another area that we're looking at. We also have a modeling aspect in the sense of for people who are interested in sort of the quantitative modeling aspect of these kinds of things is working on model of the interactions, because one of the big issues is in climate policy is the development of natural gas versus coal, for the simple reason that if you essentially reduce the amount of coal you use and substitute for natural gas in, say, the production of electricity, you can almost get a 2/3 reduction in the amount of greenhouse gases produced per kilowatt hour of energy produced. But one of the big things that's going to be necessary for that to happen is a global natural gas market, and natural gas, different from oil, requires very specialized methods for transportation over the ocean and the like. So the other is a large component of the sort of political economy as well as case study research. And one of the things that we're interested in here is the cook stove is in terms of access to energy for low-income people in developing countries, as well as we have projects on these areas in the interest of causing Lynn less heart failure. I'll move on. We also have collaborations. We're a part of the FSI, Freeman Splogley Institute for International Studies, but we're, as we said, the support from TomKat. And then we're also integrated in law school. We faculty teach a course there, as well as teaching courses in the business school on business models for sustainable development, or sustainable energy. So if you're interested, we'll be doing that in the winter quarter of this year. And then the last thing is just we had an annual research conference, and the idea here is really to transfer the best available academic research to industry and policymakers, since one of the big things is we can all sit around and think we're really intelligent, but if we don't get out there and communicate what we've learned to those folks that are making the decisions, it's not going to have much of an effect. So these were the topics of the various sections of the conference. And in order to ensure the real-world relevance, we had for each of the sections, we had a discussant from the industry and the policymaking community. And once again, these are available on the website, and there's some quite interesting interchanges between both the speakers and discussants that I'd recommend. The last is just, oh, we're done? Okay. So the last thing I just want to say is if you're interested in this sort of stuff, we have an opening for a PhD student or some researcher who would like to talk, so come up afterwards and talk to us, and we'll finish up there. Okay.
Uh-oh.
What happened to my slides are not working? Oh boy, it's not good. Is there any way to make it so that it's the zoom, so that it's not as large? Because we're getting about, oh, it's working on there. Okay, very good. All right. So I'm going to talk about SEEPAC, the Stanford Environmental and Energy Policy Analysis Center. SEEPAC is a relatively new entrant onto the Precourt scene. We've been in existence just since last winter. There are some overlaps with the focus of SEEPAC with the foci of the other centers within Precourt. In fact, I think a lot of the centers overlap. And what's good is that there's good interaction among them. For example, Frank indicated that there's a nice synergistic relationship between his center and TomCat. There is some difference in emphasis, though, and I'll try to make that clear as I talk here. The focus here is on policy analysis. So we look at different energy and environmental policy options, evaluate them, and also try to design some policy alternatives that may be improvements relative to the status quo. Let me give you a sampling of some of the policy areas that we are focusing on. One is coordinating state and federal climate and energy policy efforts. Now, many of us have been dismayed. You might be saying, well, what do you mean by federal climate policy? Is there any federal climate policy? Well, it's true that things have been stalled in Congress, but under the endangerments finding, the EPA would then take over and is expected to take over in its own ways to try to involve climate policy. And then in terms of at the federal level, there are many existing energy policies such as CAFE standards. So let me give you one example of how a coordination issue may be important. How many of you are familiar with the Pavley greenhouse gas per mile regulations? Fran Pavley, assemblywoman from California, successfully introduced a law that would put a limit on greenhouse gases per mile from California automobiles. And indeed, from automobiles, 13 other states joined in. And it was estimated by the California Air Resources Board that this would achieve about 25% of the reductions that are envisioned under California's AB 32. Sounds good, but a limit on greenhouse gases per mile. But the issue of coordination looms large here, because a limit on greenhouse gases per mile is effectively, assuming that the fuel composition doesn't change much, it's the same as a floor on miles per gallon. So these 14 states have put a floor on miles per gallon that's effectively tighter than the floor that's under the federal standard, the federal CAFE standard. What does this mean? It means that the auto manufacturers, once they meet the tighter standard of the 14 states, including California, have now more than met what was previously the binding federal standard. It's no longer binding, which means they're now freed up to sell more gas guzzlers in the other 36 states. And economic analysis and other policy analysis indicates that, in fact, what this can lead to is a huge amount of leakage, that the reductions in the 14 states, by virtue of the Pavley rules, would be entirely offset by increased emissions from the sale of more gas guzzlers in the other states, from the automobile manufacturers who are no longer bound by the federal policy. So just to give you an example of some work on this, what we've done is done some simulation analysis of this, and what we see is that if you just look at what happens in the 14 states, you get this kind of reduction in gasoline consumption as a result of this effort by the 14 states. That's the dashed line. But once you take into account what's happening in other states, a good part of it is being offset. In fact, in the short term, 85 to 90% of it is offset by increased gasoline consumption elsewhere. And in the long run, it's about half of it, or a little more than half. So this issue of coordination is important. One thing that my center does is it provides this analysis. I like to think that this analysis was instrumental in helping achieve an agreement between the Obama administration and the California and the other states, in that they ultimately replaced this Pavley rule with a more or less comparable increase in the federal standard, which avoided the leakage problem. But coordination remains, and I don't have time to get into it, but it also applies to renewable portfolio standards, renewable energy standards, and other policies that are being introduced both at the state and federal level. Another issue is assessing, well, more broadly, is trying to bring developing countries into the fold in carbon policy. And what we have now is the Clean Development Mechanism. I assume that most of you are familiar with that. It's a kind of offset mechanism. As Michael Warr and others at Stanford have indicated, there's some real problems with offsets in that a lot of the claimed reductions are not actually real.
So one of the things that we're working on at CPAC is to try to come up with improvements to the CDM and indeed some more radical approaches that would eliminate some of the problems of the CDM, while at the same time maintaining incentives by developing countries to reduce emissions. I'll very briefly indicate 2 other areas. This is just a sampling, providing incentives for the design of recyclable electronic products. And we're involved with some folks at the business school on this. And reforming the Endangered Species Act, this is an attention to a biodiversity issue. So the issues of CPAC are not only energy per se, but also the environment. The focus, as mentioned, is on policy analysis. And that means that we're looking not only at cost effectiveness, that is, what is the cost of different policies to reduce energy use or to protect the environment, but also looking at the fairness issue. How equitable is it? That's important as well. Efficiency and cost effectiveness are not the only issue. And thirdly, we want to think about the politics to see what are the political constraints and how can policies be designed, hopefully with relatively little sacrifice of cost effectiveness or fairness, so as to overcome the political constraints. I would call it economics plus in the sense that in keeping with these criteria here, we're not only invoking economists to map out the cost effectiveness implications or who gets helped and who is hurt, which relates to equity, but also looking at the legal impediments by bringing in legal scholars, political scientists to think of the political constraints, and ethicists to help further with the equity issues. And although the focus is on social scientists, we obviously want to continue to build bridges and take advantage of the others at Precourt with engineers and natural scientists in order to make sure we're asking relevant questions, that we have the underlying information or technical information correctly, and thus make us more effective. But as Jim Sweeney said, in a sense, we're not just focusing per se on what we can do to reduce the most energy. We're thinking about the combination of reduction of energy and other factors that would lead to the highest social welfare. So in some sense, it's broader than energy per se. It's social welfare oriented. Finally, there's an outreach component. As with the other centers, we want to involve representatives from government, business, and NGOs, particularly in the workshops that we have, and get their input. And the absolute last point is that there will also be a communications effort. That is, that we'll try to bring out our findings through the website, through policy briefs, and through our working papers. Thanks.
Okay, so I'd like colleagues to join me up here on the stage. If we could have the projector off, we'll sit down. And now we're open for questions. I will remind you that this is a class, so students get first access to the questions. So students, please get your hands up, and you can ask any of us anything you wish, but we're hoping for things that we know the answers to. So questions? Anybody? Here.
I actually have a question. So I understand that these organizations kind of fall under the umbrella of the
Precourt Institute.
Yeah. Sorry. What I'm trying to understand is the interaction between all of them, and also kind of how we as students could, I guess, take part and be involved.
Mm-hmm. Okay, so it's a really good question, and so let me answer very briefly, and then I'll turn it over to my colleagues to comment as well. So if you look at all the money we spend on research here, the huge bulk of it goes actually to support graduate students and postdocs. But I suspect that your question is not just about graduate students and postdocs, it's also about undergraduates. I know in my own lab I've had undergraduate students work many times over the years, and I suspect my colleagues have as well. So there are opportunities. And so one of the things that we hope to be able to do is to make it possible for students to find who's working on an area that they might be interested in, so that they can go camp on their doorstep and persuade them to take them aboard. Anybody else want to comment on that?
Well, let me just add one thing. Like Precourt Energy Efficiency Center piece, half of our expenditures total has been going to cost of students, stipends and others. Those go through projects typically sponsored by a faculty member but that doesn't mean always that the faculty member initiates them. We've had a lot of them initiated by a student in some department. They talk with a faculty advisor and say, well, wait a minute, you know, go to PEEC and you may be able to get a little grant or a big grant, and this will support some of the things that we're doing. They come to us and we evaluate it. You got to have the faculty member in the student team, but we've done a fair number of little ones like that, that as far as I can tell, initiated entirely by the students through a faculty member coming to us.
Yeah, and there are also a number of student organizations that we've actually provided a little help for as well, and we're happy to continue to do that. Other questions? In the back.
In terms of making policy for admissions for particular states, how would you respond if someone made the claim that certain states have different amounts of commuting than other states? So some states wouldn't even have a problem with commuting because they don't commute.
Yeah, so Jim or
Sounds
Larry,
like an equity issue.
That's one of you guys.
Well, yes, the vehicle miles traveled or the amount of commuting time does differ across states. And when you introduce policy, one of the equity considerations is what would that imply in terms of the differential cost for different states? And you can try to build that into policy. For example, if you introduced a gasoline tax in different states, or a uniform national gasoline tax, just imagine that for a moment.
Yeah.
Different
if
states
I were
would be
king,
affected.
that would happen right now.
But one way you could, it turns out like the average Wyoming citizen would be affected more than the average New Yorker because of different amounts of reliance on gasoline and different amounts of travel. One way you could try to offset that is to take some of the revenues from the carbon tax and rebate it to different states in different proportions based on the different amounts of driving involved, and try to offset the effect.
Okay. Anybody else? I see one. Is that a hand back in the middle back there? Or are you just scratching your head? Yeah. All right, one over here.
I haven't been a student here for about 30 years, but I'd like to congratulate CPAC. I think that's an exceedingly important effort. There's so many ways to drop the ball between engineering and science and government and actual policy, that informing people who set policy as to what actually is making sense and what isn't making sense is exceedingly important. I really think that's a great effort that you're doing, and I hope you do more of it. I have one question, though. It seems to me there are a couple things missing from what I saw that you were researching. And I'll first just mention something relatively simple, and that's the nanotechnology for electrical storage via the ultracapacitor. Why is that not being studied at this live group?
Well, actually, well, first Stacy and then ZX.
Yeah, I mean, that's certainly being studied. Those sorts of things are being studied at Stanford. So we weren't talking comprehensively about, there are a number of other centers that weren't represented here that are carrying out research of the type you're describing.
Mm-hmm. And actually, we just funded some work on paper Supercaps through the Precourt Institute seed funds. So we actually have done some there. ZX?
Yeah, in the 10 boxes I showed, one of the boxes is precisely that.
Okay, because that has the potential for being non-polluting and no chemical dangers and so forth.
Yeah, so this idea that it actually cuts across a number of these programs, but the fact that we can control structures at very small scale now creates a whole set of opportunities that I think we're only just beginning to scratch the surface of, both from the standpoint of making these things and characterizing them, but also from the standpoint of being able to calculate and predict what happens in a way that you can close the design loop. So there's much more to be done that's exciting in that area. Other questions? In the back.
I have a question for Stacy. Can you talk a little more about how the mission of the TomKat Center differs from that of GCF?
Oh, the mission?
Differs from GCF, yeah.
Yeah, we're trying to bridge between some of the detailed research that GCF is funding and other aspects of getting to a sustainable system. So For example, we're not trying to reproduce what GCEP's doing. We wouldn't be funding specific research on photovoltaics because that's already covered well, not just by GCEP, but by several centers at Stanford. But the type of thing we would focus on is, development of photovoltaics that also takes into account the land usage consideration. So tries to tie in broader concerns than is being looked at just from the technology alone.
So another example is the project that Frank is working on with a faculty member from electrical engineering is one that's it's really beyond the mandate that GCEP can pay for, but we can do it through the TomKat Center because it doesn't have quite the same funding restriction. So they're complementary in lots of ways. Back here.
Can I actually ask the same question for PESD and CPAC?
All right, fight it out. Who wants to go first?
You want to take it, Frank? Good question. That's the same question I asked Larry.
Yeah.
Okay.
So when earth scientists say that, that's because they're stalling for time to try to think up some answer. But I'm sure that doesn't happen with economists.
We were here first, so I asked Larry to join me. He didn't want to. So
well, we get along actually. But I would say the slight difference is that we have a focus on some environmental issues that are not directly energy related. Whereas I think it's fair to say that PESD has more of an exclusive energy focus. PESD also tends to work more on sustainable development, as the name implies, than we do. But we're just a fledgling operation, so in some sense, our focus hasn't been fully defined. A lot depends on the interests of the various affiliates to CPAC, and that can change from time to time. One other thing, by the way, a while ago I said just imagine a federal gasoline tax. What I meant to say is imagine a federal gasoline tax increase. Just in case I flummoxed you on that one.
Yes, we do.
I'd like to answer that slightly differently, because the fact is that there aren't such clear distinctions between what the three centers do. I funded some of Larry's work. We all know each other well, we're colleagues. We just don't do the same projects, but the projects may be conceptually within the same space. So I actually don't think it's important to say, we do that, you stay away from my territory and we do that. We really blend it together, but we don't fund the same project.
Yeah, and I would say also too that if you look at the spectrum of faculty members who work on all these kinds of things, what we're really trying to do is to use these respective centers, because the CPAC is joint with the Stanford Institute for Economic Policy Research. So that's a way to draw in and engage all the people who work through CPER in a set of problems that really demand that expertise. The Freeman Spogli Institute for International Studies, which is the home of PESD, engages, again, an overlapping, but another group of people, particularly with an international focus that's very important. And then Jim and his group is really trying to bring together pieces of the behavioral sciences that go with, for many of us, we could use energy in our own businesses and homes in ways that would save us money and would improve efficiency, but we don't do it. So why is that? Well, I think it's mostly because we don't pay attention. But in any case, the question of how we get people to pay attention and how we engage the behavioral scientists as well is another thing they're trying to do there. So we're really trying to send the tentacles of intellectual activity out across the university in a way that will engage talented people that we need to use for all this.
Could you describe the Industrial Affiliates Program and how PEI is working with them?
Yeah, so the Industrial Affiliates Program is meant to be a matchmaking service, in a sense, between companies who want to support research here at Stanford and faculty research groups. So what it largely does is to help companies find the people who are working in areas that they are interested in and provide a way to support students in that setting as well. And the focus here, it's not just the Precourt Institute, it involves it's the energy and environment area, so it involves people that are also associated with the Woods Institute. And so it's a mechanism for companies to find the right people and provide support.
In the near future, when we're still working with fossil fuels, is anybody making a quantitative estimate of the externalities that are associated with oil or coal or stuff? Is anybody doing it here?
Yes.
Yeah, all three of us have had our own quantitative
I'd
estimates.
like to see it. Is it published?
There's a huge literature on that, to say the least.
Yeah.
It's
a
massive
huge literature. It's massive.
But if you give me your card, I'd be
we
happy to send you some articles.
Good.
Before you end, I will have a very political statement I'd like to make, so give me a moment.
There's one over there, Lynn.
Okay, so we'll do one more here, and then I guess I'll give Jim the last word with some trepidation.
So this is a question for Stacy. You mentioned research into grid architecture and kind of demand response and effectively integrating renewables. You mentioned tiered pricing structures and essentially non-dispatchable demand response. Is there research into dispatchable demand response, like direct load control or ancillary services that could be provided by direct load control?
Yes.
Yes.
Okay. So, Frank, you have research going on in that area.
Okay, Jim, you're...
Here's a very political statement. California has passed AB 32, the Global Climate Solutions Act. We now have a big challenge against it, a initiative, Proposition 23, which would reverse 32, which essentially would put it on hold virtually forever. I think those who really care about global climate change should pay an awful lot of attention to the challenge posed by AB 23. The polls show that it's neck and neck right now. And if we were to pass Proposition 23, it would give a signal to the rest of the country that even Californians don't care about the environment and want to back off. May set things back in the rest of the country. And it probably will allow lawsuits to challenge almost all of the other laws that reference AB 32. So my political notion, I know where I stand. You can know whether where you stand in which direction. But this is a point where getting involved through newspapers, through letters to the editors, whatever you do, can actually make a difference to how this proposition comes out, and it may be very important to all of our environmental future. So that's my real political statement. Maybe it's, you know, be activist on this if it's important to you.
So I just say one more. If you're interested in this topic, in 2 weeks' time, we will have, I think, Jim or Larry, Jim is going to, we'll have a seminar that will talk a little bit about what's involved in AB 32, and then we'll have Tom Steyer, who's actually one of the sponsors of the TomKat Center, but he's been involved in this, in working on this, and he'll be here to talk about some of that as well.
For more, please visit us at stanford.edu.